Good morning, everyone.
Good morning, teacher.
Good morning, sir.
Good morning. Do you have any challenging numbers among the numbers we had discussed last time? About alpha and beta as roots. Remember, we had introduced roots of quadratic equations, and we are looking at the definition in general. Whereby we had said ax squared plus bx plus c is equal to 0. And with this, we had seen x squared plus b over a of x plus c over a is always equal to 0. And this helped us get to realize that if you have x squared minus alpha plus beta of x plus alpha times beta is also equal to 0. And that showed us that the sum of the roots, which is always alpha plus beta, is always a negative b out of a, and the product of the roots, alpha times beta, can be described as c out of a. So we had seen what to find. In case a question is asked, they can ask you to find alpha plus beta, alpha cubed plus beta cubed, alpha squared plus beta squared. Now we are going to have this information also used to find equations. They can give you roots, and then they ask you to find equations. But before that, let us have a reminder, a review number here, which says, given that 4x squared has roots alpha and beta, form a quadratic equation whose roots are root of alpha and the root of beta. So this is what I've been saying, that they can give you roots of a given equation, then they ask you to find an equation whose roots are in terms of alpha and beta, but in a different state. We have been seeing that equation is given with roots of alpha and beta in the form alpha and beta, but now here we are being given to find the equation whose roots are, for example, the roots we want are root of alpha and the root of beta. But from the equation we have, which is 4x squared plus 3x plus 9 is 0, you can see that x squared plus 3 over 4 plus 9 over 4 is 0. So the sum of the roots is alpha plus beta in the beginning, which is equal to negative 3 out of 4. Then the product of the roots is equal to 9 out of 4. So having realized that, that is the definition of the equation given. They want us to find an equation whose roots are. So the new equation has roots, root of alpha and root of what? Beta. So sum of the new equation will be root of sum of the roots of the new equation, root of alpha plus root of beta. And this can be seen from where? If you to go and check out from square root of alpha plus square root of beta, when you square them, you realize alpha plus beta plus 2 root of alpha beta. When you get the square root of this one, you can get root of alpha plus root of beta as the square root of alpha plus beta time plus 2 root of alpha beta. With this reason, we can get the square root. Alpha plus beta up there we saw is negative 3 over 4 plus 2 times the root of alpha beta, which is 2 times the root of 9 over 4, which will give us square root of negative 3 over 4 plus 6 out of 2. Okay, plus 3 out of, okay, plus 3 alone, because the 2 will divide with the root of 4. So plus 3 out of 1. Okay, out of 2 times 2, the 2 now cancels. Now, this root will give us 12 minus 3, which is root of 9 over 4, and the answer is 3 over 2 for the sum of the roots, which is root of alpha plus root of beta. Then their product of the roots is equal to root of alpha times root of beta, which is going to be square root of what was alpha and beta, a square root of alpha times beta, which is the square root of 9 over 4. And this gives us 3 over 2. So with this sense, the general definition is x squared minus the sum of the roots. If you want to derive the equation, times x plus product of the what? Product of the roots is equal to 0. Now, our roots of alpha, root of alpha plus root of beta, their sum has been, what sum did we get? We got a sum of 3 over 2. Then we have got a product of also 3 over 2. Hence, the equation is 2x squared minus 3x plus 3 is equal to 0. Hence, we have derived an equation whose roots are root alpha and root beta, having been given a definition of what alpha and beta can be in terms of sum and in terms of product. Of course, they will not give you the sum, but it is you to find out what is the sum and what is the product of root 2. What is the product of alpha and beta? What is the sum of alpha plus beta using the equation that has been given? Okay, unless if someone has a question. Any question? I sent you some numbers there to try out. I don't know whether people. Yes, please.
Sir, may you repeat from the new equation?
Okay. The first part is okay, I think.
Yes.
Now, when they want you to find the new equation, they will give you the assumed roots of that new equation, like this one and this one. That these are the assumed roots of the new equation. So get the sum of those new roots. Their sum is this one. But you cannot easily add this one. You have to express it in terms of alpha plus beta and in terms of maybe alpha times beta. By so doing is by investigating its square. When you investigate its square, it reduces to this because it comes to root of alpha plus root of beta. When you square it, you get root of alpha squared plus root of beta what? Squared plus 2 root of alpha root of what? Beta. That's how it becomes alpha plus beta plus 2 root of alpha beta. Then now you have expressed it in terms of alpha plus beta and alpha times beta, then get the square root on both sides and make root of alpha plus root of beta the subject, which reduces to this one. Then you substitute the root alpha plus beta, you substitute the square, you simplify, we got that as their sum. Their product is easy, direct, you just multiply and get the root. Then you come back to the general definition in terms of roots, whereby it is x squared minus sum of the roots, as you can see here, plus the product of the roots, times x plus the product of the roots is equal to 0. Okay. Is that better? Yeah? Are you there? Has it gone off? The other question, yes, Namirembe, Mama Gembe.
Yeah, I'll go back to the previous page.
Okay.
Okay, thank you. So I'm done.
Example, find the roots of the quadratic equation and the roots of the quadratic equation x squared minus 6x plus k is equal to 0, given that one root is 3 times the other, and that k is a constant. Find also the value of k. So the equation is x squared minus 6x plus k is equal to 0. They have told us one of the roots is 3 times the other. I can assume one root, let one root be a. The other root is supposed to be 3 times that root, not so? Whereby the sum of the roots is going to be equal to a plus 3a. And that sum of the roots actually is going to be equal to negative of negative 6. That is how it becomes a positive what? Remember, some of you, we said you can cram if you don't see how we can modulate the negative. Yeah, whereby if it's a negative there, it's a plus, the sum. When it's a plus, then the sum is negative. So when you divide the two, what do you realize? Realize that a is equal to 3 out of 2. So the other root, if that is now the first root is 3 over 2. So the other root is thrice that one, giving us 9 over 2. Okay. So if you know the other root, what is k? K, remember, is the product of the roots. So k is supposed to be equal to a times 3a. You realize that this is going to be 3a squared, which will be 3 times 3 squared out of 2 squared. And this will confirm 27 out of 4 is the value of k. Questions?
Teacher, how are we getting k as a times 3a?
How are we getting?
K as a times 3a.
And the roots are a and 3a. Do we agree? This is your alpha. This is your what? So if you merge these two, you get alpha times what? Is equal to k. The reason why it's k because this one has a coefficient 1. If there was a constant here, you would first divide through by the what? By the constant. So the product of the roots, which is a times 3a, is equal to k. That's how I got a times 3a. It's okay even if someone had assumed that the roots are alpha, then the other one would be 3 alpha. Then you first find alpha. I've just wanted to change the letter to a little so that you don't oversay that all the time it's alpha and beta. What if they change a little and they say the roots are a and b? Will you get confused? No. Though the most common books talk about alpha and what? And beta. Any other question? No question. Screenshot. Given that the sum of the squares of the roots of the equation ax squared plus bx plus c is equal to 0 is 1. Show that b squared is equal to a squared plus 2ac. Swale, your hand is up. Swale.
Sir, may you repeat the explanation of the other root?
Hey. And they say, you assume one of the first roots. It could be what later? So you assume for me any letter to be the root, the first root.
B.
B. If you assume the first root is B, the second root they have said is what? Is 3 times the other root. So the second root should be what? 3b. So sum of the roots will be b plus 3b is equal to what? Is equal to positive 6. Then b will be equal to 3 over 2. Product of the roots will be b times 3b is equal to k. Okay? So did you get that?
Yes, sir.
Okay. Now, to start with, we know very well that x squared minus sum of the roots times x plus the product of the roots is equal to 0, whereby x squared minus the sum of the roots is, of course, alpha plus what? Beta times x plus alpha times beta is 0. According to our quadratic equation, it is in line with x squared plus b over a of x plus c over a is equal to 0. What does that mean? It means the sum, which is alpha plus beta, is equal to negative b over a. The product, alpha times beta, is equal to c out of a. Now, the question has said what? The question has said, prove that or show that b squared is equal to that. Why? Because they have said the sum of the squares of the roots is equal to 1. So if the sum of the squares of the roots is equal to 1, they have said, given that the sum of the squares of the roots of the equation is equal to 1. So in that sense, we need to review. If you have the sum of the squares of the roots, if the roots are alpha and beta, so alpha squared plus beta squared is equal to alpha plus beta squared minus 2 alpha beta. If if you recall, this sum of the squares is supposed to give us 1. Recall, if you have alpha plus beta and you want to expand it, it is alpha squared plus 2 alpha beta plus beta squared. When you make alpha squared plus beta squared, those are the sums of that is the sum of the squares of the roots. It becomes alpha plus beta squared minus 2 alpha beta, which is this one. But that whole sum is equal to 1. For that reason, I'll have a negativity of b over a squared minus 2 times c out of a is equal to 1. Algebra, b squared over a squared minus 2c out of a is equal to 1. So b squared minus 2ac is equal to a squared. Therefore, in totality, this becomes b squared is equal to a squared plus 2ac. Hashtag solution. So proofs are also on the way. As you can see, they can ask you to derive, they can ask you to show, they can ask you to find the equation. So we are now just manipulating roots of quadratic equations. The definition came last week, so now we are manipulating it into any other possible questions that can arise. Questions before I go to the next number. Okay.
Sir,
Yes, please.
on this first number,
Mm,
where there is -6,
mm.
you said that 6, it is when you add a plus 3, it's a +6. Why did you neglect the negative?
At Munai, there might be some new students who do not know how. Why did I neglect the negative? And negative times negative, positive here.
Yes.
Negative times negative, you get what? Positive. And then the other thing is I wanted to show people that you should be reminded that alpha plus beta is always equal to a negative of the coefficient on x. So the coefficient on x is -6. So it is alpha plus beta is equal to a negative of that -6, which is a positive. Reason I don't want people to overcram. Otherwise, one can always cram that the sum is a positive if it's a negative up there. The sum is a negative if it is a positive up there. Yeah?
Yes, teacher.
Okay. Here's another number. Just know we are just enjoying different numbers to see how these questions can always be set. Given that only one person sent me, I sent you the page of numbers. Did you try them out? Only one person was consulting. Given that the roots of the equation, like you see, no one will always push you to solve numbers in A level. But the more you solve, the better advantage you have. Swale, your hand is up. Swale.
Excuse me, sir.
Yes, please.
So may you take back a little bit to the first page?
First page.
Yes, I have a simple question there.
The first page or the page before?
The first page.
First page. 2, 1. Okay, there.
So when getting the sum of
When getting what?
getting the sum of roots.
When getting what?
When getting the sum of roots of the new equation.
At the sum I showed you, I asked myself, where can I get this sum from? So I investigated its square. When I investigate the square, it becomes that. So I finally can make root of alpha here plus root of beta, the subject, by finding the square root.
So we are supposed to use the square of the roots.
You're supposed to use on this second term. No, now aren't you have to express that function in terms of alpha plus beta and alpha times beta. Whatever they give you, that's why they give you alpha cubed, beta cubed, but you express it in terms of alpha plus beta, alpha times beta. So everything is to be expressed in terms of the sum and the product of what the first equation has given you. You are expressing it in this form. And this one.
Okay.
Okay, here we are. Given that the roots of the equation, that one, are in the ratio P to Q, then show that. It means if I have alpha and the beta as the roots, so I can let alpha and the beta be the what? The roots. Then these roots are in the ratio of P to what? To Q. It means alpha over beta is ideally P out of Q. Okay, so if that is the sense, we can see that x squared plus b over ax plus c over a, here you know what I'm doing. You can confirm that the sum of the roots, which is alpha plus beta, is supposed to be equal to negative b out of a. Then the product of the roots is equal to c out of a. Okay, so with that sense, remember we have seen that if you have the ratio as given, if alpha over beta is equal to P out of Q, then consequently, alpha is equal to P, beta is equal to Q. So if alpha is equal to P and beta is equal to Q, then we can substitute and say PQ is equal to C out of A. Then P plus Q is equal to a negative B out of A. Now, if that is the sense, you can see that A PQ is equal to C. Okay, you can make A the subject, which is A is equal to C out of PQ. So if A is equal to C out of PQ, when you look at negative B is equal to A into P plus Q. I can substitute for A and say negative B is equal to C out of PQ into brackets P plus Q. When I square both sides, I'll get a negative B squared is equal to C squared out of PQ times squared times P plus Q squared. This will realize B squared as equal to wait, where is the B? Something I've missed here. Let me take the B from here. When I square it from here, what will it give me? When I square it from there, you're going to have negative B squared is equal to A squared into P plus Q squared. So this will give me B squared is equal to A squared into P plus Q squared. So with that, you can here you see that you have B squared is equal to A times P plus Q squared times A if I split the A's. But remember, we have seen A is equal to C out of PQ. So because the question still has some A in it, I cannot eliminate the A's entirely. So I'll have B squared is equal to 1A is C over PQ times P plus Q squared times A. With this, you can see P squared times PQ is equal to CA or SC into P plus Q close brackets squared. Hashtag solution. The proofs become a little bit interesting or challenging if someone has not been solving entirely. So if you have no questions, you can screenshot that. Most of these numbers are in backhouse, so I'm solving your exercise idea. They'll give you a number which will have a quadratic equation with common roots, or quadratic equations which have common roots. They can give you two quadratic equations and both of them have a common what? Have a common root. Yes, Monica, your hand is up.
Teacher, I got lost. Okay, I tried to understand that upper part, but here where I introduced when you started solving for negative B,
And
I don't
squared.
understand why I'm using an A.
Yeah, now I had seen what A is. Now, when you look at this equation, none of the letters has been eliminated. So it means all the letters have to exist. So if you're substituting, you don't substitute entirely. So it means if I square B here, which is a negative, I get B squared. When I expand this side and I square the A and the P plus Q, I get A squared P plus Q. Now, because I've seen A is still existing, I cannot substitute entirely for A by squaring. So what do? I substitute for one A, I leave there one other A. So I have substituted for this one by doing that, then I simplify it. Otherwise, if A was not there, then totally you had to substitute for that. And you'll find some equations which are in that form. Okay, so here we are, derive condition such that the equations x squared plus ax plus b is equal to 0 and cx squared plus 2ax minus b minus 3b is equal to 0 have a common root. So here we are, they are giving us have common root, a common root. So if they have a common root, you can let in the beginning of this presentation. If they have a common root, does not mean that they have common roots, both of them. The questioner said have one common root, even if they don't mention the word one common root. They have said they have a common root, so it is one common root. So what does that mean? It means if you let the common root be alpha, then when you substitute that root, which is alpha squared, where there is x, you will get a alpha plus b is equal to 0. In the second one, you'll get c alpha squared plus 2a alpha minus 3b is equal to 0. So we can eliminate alpha, for example, by saying if this is equation 1, this is equation 2, you can say twice of equation 1 minus equation 2. Then you'll get 2 alpha squared minus c alpha squared plus b minus 3b. 2b minus 3b is equal to 0. In this sense, you can get alpha squared into 2 minus c is going to be equal to, this was subtraction, so this became a plus 5b is equal to 0. Then you can get alpha squared as equal to 5b out of 2 minus c. Now get this alpha squared and substitute it back. up there. No, before I can actually get alpha squared, let us try to also eliminate c squared. Can I rub off this number? I don't want to lose the page. Take a screenshot, I rub off this number. So having rubbed off, so I can also eliminate c squared. I mean alpha squared. When I eliminate alpha squared, I can find alpha. How? By multiplying Roman 1 by c minus Roman 2. This will give us c alpha squared plus 2 plus sc. Let me first show you this one. Plus bc is equal to 0. The second one has c alpha squared plus 2a alpha minus 3b is equal to 0. When you subtract, for the other one, I did not show you this. It was a little bit more obvious. This one has unknowns, it's very tricky. So 0, eliminated alpha squared, then you get sc minus 2a alpha plus bc plus 3b is equal to 0. Then you realize that you can get alpha as equal to a negative b into 3 plus c, or is over sc minus 2a. This is alpha, equation star 2, and this was alpha squared, equation star 1. When you square, what will happen? When you square, you're going to have b squared into 3 plus c squared all over a squared into c minus 2 squared is equal to 5b out of 2 minus c. 2 minus c is the same as c minus 2, as long as this one is squared, even if you reverse them. So I can alternate by saying 3 plus c squared out of a squared into 2 minus c squared is equal to 5b out of 2 minus c. Then I can vamoosh 1, 2 minus c. From this side, I remain with 1 here. Finally, we can have the last expression as b squared into 3 plus c squared is equal to 5b a squared into 2 minus c. And that is our solution. Okay. It's all about now knowing how to solve simultaneously in these cases where we have common roots. And if you can solve very well, then you can manipulate whatever the question wants. I'm going to give you one last example on this one. Though these were all numbers from Backhouse 1, maybe if by chance, I'm going to check in my counter here. If I have some interesting ones, I'm going to send them as well. Okay, we have some two more numbers to try out. You will take a screenshot. In case of any questions, please go ahead and ask.
So I don't know how the 2 minus 3 cancels out with the 2 minus 3 squared, yet they're on different parts of the equal sign.
This is what happens. B squared into 3 plus c squared. when you cross multiply, you get 5b times a squared times c minus 2 squared over c minus 2. This one over 1. So it's the same as even if you've not cross multiplied. Yeah? Even if you've not multiplied, we can still divide from the other side, because we know the best it can do is to cross and go to 5 plus times b. So if it goes there, it becomes a numerator. So that numerator can be reduced by division. That's why we divide on both sides. Okay. Show that if equations x squared plus bx plus c is equal to 0 and x squared plus px plus q is equal to 0 have a common root, then c minus q squared is equal to b minus p times cp minus bq. The idea is the same. Should I let you try out this one? Problem, when I let you try out, people don't return to me. We can take 20 minutes when no one is giving an answer. But okay, let me do all these numbers I prepared so that for you, your job is to visit any other numbers that show up and you handle them. When they fail, of course, you consult the teacher, but starting with your group friends. So if these are our equations, we can first eliminate, for example, I can eliminate x squared. Okay, before I eliminate x squared, we can let the common root be what? Alpha. So alpha squared plus p alpha plus q is equal to 0. Alpha squared plus b alpha plus c is equal to 0. When you eliminate alpha squared, we shall get p minus b of alpha plus q minus c is equal to 0. And we can make alpha the what? The subject, which is c minus q out of p minus b. Vision star. Then the second part is to eliminate alpha what? Alpha squared. I mean alpha alone. If you have to eliminate alpha alone, it means multiply the numerator. You can multiply the numerator.
Is it c minus q or q minus c?
And cut now, when it crosses over, it becomes a negative q minus c. Then the negative penetrates. Okay? Have you seen that?
Yes.
Yeah. Then furthermore, I can multiply if this is our Roman 1 and this is our Roman 2. I can multiply Roman 1. Roman 1 can be multiplied by b over p, then minus Roman 2. If I multiply Roman 1 by b over p, I'll get b over p alpha squared plus b alpha plus q is equal to 0. Then the second term will be alpha squared plus b alpha plus c is equal to 0. Remember, I want to make alpha get lost. So to remove alpha, we have to subtract. On subtraction, I'll get B out of P minus 1. This is alpha squared plus Q minus C is equal to 0. Hey, this one has a B out of what? Out of P. So this is going to be B out of P. Therefore, alpha squared is going to be equal to C minus cube B out of P, all divided by B minus 1 over P. You see that alpha squared actually becomes CP minus cube B, all is over P, divided by B minus 1, all is over P, and the P can vanish. Finally, this becomes CP minus cube B, all is over B minus 1. If that is alpha squared, we have eliminated everything. Now we can square C minus Q over P minus B. This can give us CP minus QB, all is over B minus 1. How did I get B minus 1? It's supposed to be B minus P. This one, because the P crosses up. This was impossible. It is B minus P. But I told you B minus P is the same as P minus B if one of them is squared. So this means C minus Q squared is equal to CP minus BQ times B minus P squared over B minus P. Vamos that. We shall have C minus Q squared is equal to B minus P brackets CP minus BQ. Hashtag solution. Are we happy? Or there is someone there who is unhappy? Okay, we have to introduce one more last number. So we shall have another, after this, next week we shall introduce remainder theorem. Then when we finish remainder theorem, we shall go to coordinate geometry. Then after that, we shall introduce differentiation. If God allows, and we go up to January and you guys are still here, at least we should have gone when we have covered like 3/4 of Backhouse 1. When you go, when you're that excited, trust me, with that morale, you will enjoy the mathematics. Unless if you're not serious, but if you're serious, you will love the mathematics. Okay, any questions here? No question, let's have our last example packaged for today. Given that the roots of the equation, given that the roots of the equation 2y squared minus 3y plus 5 is equal to 0 are alpha and beta. Are alpha and beta. Form an equation. Form an equation whose roots are alpha over beta minus 2 and beta over alpha minus 2. Yes, Josh, before I can go for the number.
Say the previous number.
There you go.
How did we get that C minus Q over P minus B?
How did you
Squared,
get what?
like both of them squared. C minus Q squared minus out of P minus B squared.
Hey, this one, eh? Yeah? Is that the question?
Yes, sir.
Now, do you remember we saw alpha in the beginning? Yeah? Do you remember us getting
Yes, sir.
alpha? So I have squared the alpha so that it looks like this one, and I equate it to that one. Does it make sense? Hmm?
Yes.
Yeah.
Thank you, sir.
You're welcome. Okay, guys, look at this number. Very interesting. The roots which have been given, they're a little bit ambiguous. They are robust. Mhm. The equation itself is in terms of y. You are used to x. It has a coefficient. The beginning should be y squared minus 3 out of 2y plus 5 out of 2 is equal to 0. I guess we agree with that. Oh, this was alpha and beta and the roots. Therefore, alpha plus beta is 3 over 2. Then alpha times beta is actually 5 over 2. The new equation has a sum of roots, which is going to be alpha over b minus 2 plus beta over alpha minus 2. Now, that is why it requires you to have understood the other first parts, and those are functions we had to deduce. So this will give us alpha squared minus 2 alpha plus beta squared minus 2 beta, or is over alpha minus 2 times beta minus 2. Algebra of expansion, we shall realize alpha squared plus beta squared minus 2 alpha plus beta. What is divided by alpha beta minus 2 alpha minus 2 beta plus 4. Is your expansion still okay? Because there's a lot of expanding here. But remember how to get alpha squared plus beta squared. That is why I'm saying the other first lesson was very vital. You get it from alpha plus beta when the whole of it has been squared, minus 2 alpha beta minus 2 of alpha plus beta, all is divided by alpha beta a minus twice of alpha plus beta a plus 4. We are now ready to substitute. We have to express everything in terms of alpha plus beta and alpha times beta. With this, you can realize thrice over 2 close brackets squared minus twice times 5 out of 2 minus twice of thrice out of 2, or is over 5 out of 2 minus twice of 3 out of 2 plus 4. The 2 and the 2 die off. The 2 and the 2, poop, poop, and the 2, tip. Therefore, we shall remain with 9 out of 4, a minus 5, a minus 3. What is divided by 5 out of 2, a plus 1, because 4 minus 3 is a positivity of 1. This will realize 9 minus 32 out of 4. What is divided by 7 out of 2. By 2 once, by 2 twice. This will give me a negative 23 out of 14. Is that okay? Let me check what I've done. Yes, yeah, that is a 3. Negative 3 minus 5, you get a negative 8. Okay, that is correct. So negative 8 times 4, you get negative 32. Very correct. Then down here, you have 5 minus 5 over 2 minus 2 times 3 over 2, yes. There's a plus 4 there, yes. 4 minus 3, you realize it is 1. I think we are correct. That is the sum. How about the product? The product of the roots is alpha over beta minus 2 times beta over alpha minus 2. This gives me alpha beta, all is over the lower expansion, we have already done it, which is alpha beta minus 2 of alpha plus beta plus 4. When you substitute, you realize 5 out of 2, all is over 5 out of 2 minus 2 into 3 out of 2 plus 4. This will give me 5 out of 2, all divided by, I lose this with that. When I divide and simplify, I get 7 out of 2. I lose the 2, so the product is 5 out of 7. So if the product is 5 out of 7, then I can say x, they have said form an equation whose roots are that. The equation should be in terms of y squared minus the sum of the roots times y plus the product of the what? Of the roots should give us 0. So y squared minus of a negative 2 out of 3 out of 14 of y plus the product, which is 5 out of 7, is 0. When I multiply everything by 14, I'll realize 14 y squared plus 23 y plus 10 is equal to 0. If you want to check whether you're correct, you investigate by equating this to 0 and see whether you get this answer, whether you get not that answer. No. These ones you don't investigate. You investigate when you're solving quadratics. So this becomes the equation. So with that, I think this is going to mark the end of roots of quadratic equations. Unless if someone has a special question on roots of quadratic equations. But those
I
of
have a
us,
question.
yes, please go ahead.
On the second line, on the second page, where I got 3 out of 2 squared minus 2 times 5 out of 2 minus 2 into brackets 3 out of 4. And you are dividing. Aren't you supposed to divide 2 into 3 out of 2 on the denominator by all the digits on the numerator? How come you never divided it by 3 out of 2 squared?
Divide the 2. Are you saying I should have divided the 2 by? Sorry is asking, is the introduction of this topic on the YouTube? Yeah, I think all the topics I'm putting them there. What's happening with your sound? Speaking. Yeah, when I say it, this is later. Hey, that's wrong with your phone. Okay, so you were asking me why I never divided by the first one. The reason why this one has been divided, it is because this is alpha times beta, which is 5 out of 2. Write it there, you get 5 out of 2. If 2 is multiplying 5, out of 2, you can divide the 2 to 1. So you get a 5. Then this one is alpha plus beta, which was 3 over 2. When I substituted it, it became 2 times 3 out of 2. I lost the 2. So this is a negative 3, giving us a negative 8. Then this is a 9 out of 4. Then 9 out of 4 minus 8, you get 9 out of 4. You cross multiply the 4 to the 8, you get a negative 32 out of 4. And this one, the same story. I think you can see that. The topic is there. Leave it with YouTube. Okay. Any other question? Yes. What? Leila, what's wrong with your phone today? Can you text maybe?
Okay.
We are waiting for Rutu's chat, then we close. Because she had some questions. You know those questions, sometimes they benefit all of us. Rutu, please send your question. Okay, there it goes. Teacher, where did you get alpha minus 2 alpha plus beta? Huh? Hey, where did I get alpha minus 2 alpha and the sum of the roots? Okay. Where did I get alpha minus? Where did you get alpha minus 2 alpha plus beta? Where is that? Alpha minus 2 alpha plus beta, where is that? Alpha. Guys, are you seeing where she's asking?
The first page.
The first page?
First page, second last line.
I go back to the
No,
first.
sorry, first part of the board. No, it's on the first part of the board which is on right now on the second last line.
Here.
Where I expanded alpha out of
Here.
beta minus plus beta.
Yes. Where did I get alpha minus 2 alpha plus beta squared? When you cross multiply this, it goes up. Cross multiply this one, it goes where? You will get alpha into alpha minus 2. You will get alpha squared minus 2 alpha. The second part is beta into beta minus 2. You will get beta squared minus 2 beta. When you sum them up, you get alpha squared minus 2 alpha minus 2 beta plus beta squared. That's how I ended up there. Leila, have you seen that? Leila, is she still available? She's unmuted, but she can't speak. Okay, guys, let's call it off from here. Thank you for attending. Please attend the lessons as much as you can. If you can't, those of you who miss some of these lessons when you come late or you have network interference, visit my YouTube channel, Lubama Hamza, subscribe, like it. You can even share it to your friends, and then you can be able to get and catch up with some of these lessons. In case also one lesson, maybe you didn't understand it very well, you can go over the video on YouTube and rewatch the video. In that case, you will be somehow restudying. Then in case you get a challenge, you come and inbox me of the challenge, or we put a comment on the YouTube, then I'll find it there and I'll respond to it. Okay, with that, we can call it a day. Thank you for your attendance and have a good day.